Can you talk a little about what the benefits are there?
I'm sorry, I really can't.
You're like, no.
So funny.
Sorry.
Still equal. I love this.
From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker.
And I'm Kaushik Gopal.
Welcome to the show. Kaushik, here we are again, my friend. Back again.
Yes, we are. It's another day, morning, good day for you. What is the time there?
9:45 in the morning.
9:45.
Yeah, that's early for you. What time? 6:45 there?
It is 6:45 for me, yes.
Oh, thank you very much for getting up that early. I know it's difficult, especially when you work at a startup where you're working all hours of the night.
No, but it is enjoyable, especially when we have great guests and great topics to speak about.
Mm-hmm. Very valuable guests.
Yeah, yes, very valuable indeed. So who do we have on today?
So we have a close friend of the show who we have spoken to and know in various other channels quite a bit. And today, this individual is kind of a expert in the area of value objects and so forth.
Mm-hmm.
He is, he's another Android GDE. He is an instructor on Caster.io and very active in the community. And with that said, I'd like to welcome to the show Ryan Harter. Welcome to the show, Ryan.
Thank you. It's great to be here.
Now, Ryan, for the folks who are not familiar with who you are, kind of your background and so forth, could you give us kind of some information about, again, your background, where you work, kind of what you do now and how you got into Android?
Sure. Let me start with how I got into Android. So while I was in college, I was a Mac desktop developer. I managed all the Macs on campus.
Oh, wow.
And so once I got out of college, the iPhone had kind of been big. So I went into mobile development. And Android was sort of, in its really early stages then. And the company I was at, a consulting firm, just didn't have anyone that did Android. So I kind of took up that, that role and became the Android lead there. And I've been doing it since 2009, 10, in that time frame. And since then, I've gone out on my own. And I actually, for the last 4 years or so, I've just been a freelancer. So I work with a lot of different companies and a lot of really cool projects, and it's been really good. Some of my personal projects, I work with 5 other guys down in San Diego, and we do graphics and entertainment apps.
Mm-hmm.
One that we're just about to release for the holiday season is called Pigment. It's a coloring book app for adult coloring. That we're really excited about.
Very cool.
I saw that. Yeah, the app looked really, really interesting. I saw I think you tweeted about it or something like that, and it looked super interesting.
Yeah, it's really fun. I wasn't into adult coloring before, but since writing that app, I've been spending a lot of my free time, just coloring in artwork, which is a lot of fun.
And I remember for folks who've listened to the show for some time now, in our last I.O. episode, you made a guest appearance and you told us some of the interesting things that you had to say. You also mentioned another app in that. Was that also Pigment at the time?
One of the other apps that we do is called Fragment.
Fragment,
actually.
yes.
So,
no, that's the one.
Yeah,
yes,
yeah.
yes.
That's a great name.
Yeah. So I hear. But Fragment is sort of for the Instagram crowd. It lets you do not really filters, but artistic edits to your photos, and you basically get to put these, we call them prismatic shapes, over your photos, which add some really cool effects and let you do some really artistic stuff.
Right. It is pretty cool, and we'll definitely add links in the show notes to both of these apps. Alrighty, so Ryan, Don and I have been super excited about this show specifically because we wanted to talk to you about some topics that we thought were extremely interesting. These are topics that Don and I spend hours and hours talking about. So this is the world of immutability, AutoValue, value types, value objects. All of these things are super interesting, and we've heard that you know a thing or two about this kind of stuff. So we wanted to talk to you about these topics.
Yeah, that sounds great. I've been working really closely with immutability and value types and all of that stuff over the last probably 2 years or so. So it's a topic near and dear to my heart.
Let's maybe start off with just the concept of immutability, right? What is, for those of us who don't know what immutability is, the graybeards and the whitebeards of our industry love this topic, right? They're like, oh my God, immutability is the best thing. We should like try to add that in because it adds simplicity, purity. Can you tell us why immutability?
Yeah, absolutely. So first of all, immutability, very simply, just is an object that can't be changed once it's created. And it's a really simple idea, but if you think about a lot of the code that we normally write, I think most of us, me at least, when I go to initially write a class, I think of it as mutable, as changeable. You can set properties on it. And what that does is that adds a lot of complexity that we initially don't think about or maybe unintuitive. So by making things immutable, so unchangeable, if you want to get a slightly different object, you need to make an entirely new copy of it. There's a lot of benefits. Namely, simplicity, like I said, is a huge benefit. And the reason that immutable objects are so simple is if you think about an object like a credit card transaction, if you can always be changing all of the properties of a transaction, the transaction time, the customer ID, like all of that, it's really easy for that object to get into a state that's no longer valid because there's so many ways that it can change. So immutability offers simplicity in that once you create it, you know that it's always valid. So that's one of the really big benefits of immutability. The other big benefit in my mind is that immutable objects are thread safe by default.
Oh.
So if properties can't change, you never have to worry about another thread changing the properties of a class out from under you.
Right.
Because it can't be changed.
If we kind of take a step back and as someone who's maybe looking at immutability as a beginner, and we're talking about how objects can't be changed, they may be wondering, well, I can just create an object. Like, how do I make a particular Java object immutable so it can't be changed? Is like, what does that look like if I were to build this by hand? How would someone go about doing that so this object could be immutable?
Yeah, so there's actually more complexity to this than you might think initially.
No way.
The simplest step, of course, is when you have an object, if you sort of follow the normal POJO, plain old Java object path, you create an object which has private members. That's important.
Yep. Mm-hmm.
And then you use getters and setters. So the most obvious choice is to just remove the setters. Okay.
Oh, okay.
So that's step one. No setters on these classes because you can't set values once they're created.
Mm-hmm.
But now we move into the things that people tend not to think about. So first of all, by default, Java classes can be subclassed.
Right. So
you need to make the class final. That way it can't be subclassed, because what you can have is you can end up in a situation where you have this credit card transaction that you thought was immutable, and some either malicious programmer or potentially some just a developer who's maybe not paying attention is going to subclass that to make it mutable. So you want to make the class final.
Mm-hmm.
The next thing you do is you make all of the member variables final. That's a helpful step. That means once they're created at creation time, you can't change them.
No. Quick question about that final thing for the member variables.
Yeah.
If the member variable is final, does that mean that I have to provide that value through the constructor?
You do. You have to provide the value at creation time.
Okay.
And so what that means, depending on how closely you follow effective Java, that could be at in the constructor. Or it could be in static factory methods.
Oh, okay, that's true.
And the other thing that you can do, speaking of static factory methods, and I may be getting ahead of myself, one of the challenges of immutable types is sometimes you want to, slightly modify something. You want to copy something and change one property. Static factory methods give you a really easy way to do that, because you can make either static factory methods that take another credit card transaction object or whatever this object might be, or you can make copy methods that will slightly not modify the existing object, but return a new object with all of the same properties with, one or a few changed. So you do have to set all of your member variables at creation time, but using things like static factory methods makes that really flexible.
Interesting. I do have a question about, I'm sure someone that's listening right now says, well, what about reflection?
Yeah.
Can I change these types with reflection?
Yeah. So that's one of the questions that we get in the AutoValue community quite a bit. And that is kind of one of the downsides. As far as I know, there isn't a way to prevent changing these values via reflection, because using reflection, you can change the modifier. So you can remove the final modifier and change the value.
Mm-hmm.
Yeah.
So one quick follow-up question that I had. Usually in the world of Android, right, initially immutability was actually seen as a negative thing. People frowned upon immutability, specifically in the Android community. Why is that?
So one of the challenges of immutability is overhead. Because you can't change values of objects, of properties on objects, that is. If you want to modify anything, you need to make a new copy, and that adds overhead for the garbage collector, for just memory management in general. And so that is one challenge, and that's one of the things that, for instance, on my app Fragment, you can modify, using your your fingers by brushing or rotating all of that. You can modify all of these settings on an image. And so initially, I tried to use an immutable state object so that I could record an undo stack. Right, that's a pretty straightforward approach. But the challenge is that when you rotate, there's so many settings in there that things are changing all the time. And so that just adds a lot of overhead, a lot of creating new objects and then letting the garbage collector collect other objects. So there are some cases, depending on how frequently your properties need to change, that immutability might not be for you.
So basically, if you have a requirement in your application where, like, because of immutability, you have like a ton of objects being generated, then maybe that's a case where you have to like rethink whether it's applicable. Like, are you actually getting the benefits of immutability? Do you think that's a fair summary?
Yeah, absolutely. And that's, in that case for Fragment, I made those state objects mutable.
I have a decent understanding now of like, immutability and like, the benefits, the disadvantages. In reference, like you said, AutoValue, right? And like, I know for all practical purposes, AutoValue is something that helps with the concept of immutability, right? So what exactly is this thing that people also talk about called value objects and value types?
Yeah, so a value type is simply an object whose equality, so when you're comparing two of these objects, is dependent on the property value, not the actual object instance. So going back to a credit card transaction, this is a good case where if we were to compare two credit card transactions, comparing if they're the same instance, like the same memory space in the JVM, it's unimportant. What we care about is if they both represent the same transaction.
Mm-hmm.
So I like to think of it as a value object. Its importance is determined based on what it represents, not its actual instance.
Oh, interesting. Okay. Recently, I saw this tweet by Martin Fowler. Martin Fowler, as we all understand, is one of like the whitebeards of our industry. Usually, if he publishes something, you should go back and read it because he has some very interesting and intelligent things to say. He recently updated his article on value objects. So we'll add a link to that in the show notes as well. So for folks who are interested in knowing more about value types and value objects, who really want to dive deep into like, the details and the nitty gritty, then make sure you have a look at that. Okay, so we have an understanding of immutability, value types, value objects. Where does AutoValue fit in? And I know, Ryan, you've done like some amazing work with AutoValue. So is AutoValue basically just a library that helps us with immutability? Like, is that its sole purpose?
So AutoValue is an annotation processor that basically helps you generate a lot of the boilerplate that goes into writing immutable value types.
What is the additional boilerplate? Because you said it's only setters and getters, right? Is there anything else that's involved? I'm trying to understand what is the benefit of AutoValue? Where does AutoValue come into that picture?
Yeah, so we talked about for immutable types, we need to finalize everything and remove our setters, that sort of thing.
Mm-hmm.
For value types specifically, there's a little bit more. So we have to override equals, toString, hashcode, all of that. And make sure that when we do compare objects, since this is a value object, that equals is true if the property values are equal, and that sort of thing. So AutoValue will generate all of that really just tedious boilerplate for you.
So you brought up this great point. It just hit me now. You said the difference between value objects and immutable objects. And I think there's like an interesting point to be told there. So immutable objects purely talk about the fact that they don't have direct references. You cannot change the values in them, right? But with value objects, there's this concept of like overriding equals and like toString and that stuff. Why would I need to do that again? Just to like refresh our memory, like why do I need to override equals? Like if I just compare to Java objects, doesn't that work? Like the equals to method typically should work, right? Or is there something else to this?
Yeah, so this touches on kind of the heart of value types. And so the way that Java compares objects for the default equals method is by the memory address of the object. So if you a really good way to see this is if you look in the debugger.
Mm-hmm.
If you set a breakpoint somewhere in the debugger and you look at a variable that you have, you'll notice that there will be a string attached to it that's sort of some nonsensical characters, numbers and letters,
like a hashcode or something, right?
Yeah. Exactly. Yeah, that's the memory address. And so the way that Java compares these is it compares the memory address. If object 1 and object 2 both point to the same object in memory space in the JVM, then they're considered equal. But that's not what a value type is. A value type says if object 1 represents the user Kaushik Gopal and object 2, a different object in memory space, represents that same user, then they're equal. And so what AutoValue does is it does that comparison by saying, does object 1's first name match object 2's first name and last name and user ID, whatever that might be.
Oh, interesting. So it actually goes through the fields, looks at their values in inverted quotes, and then establishes that relationship if they are actually equal versus just looking if X4, 5, 6 reference is equal to X1, 2, 3 or something.
Exactly. And so one of the things, just to add on that, one of the things that makes this very important is for both hashcode and equals. Equals, obviously, if you want to compare objects, you want to make sure that two objects representing the same thing are considered equal. Hashcode, a lot of us don't think about, but the reason that's really important is if you want to use this object as a key in a map, or you want to use it in a set, sets can only have one of each object, right? So equality is really important there, and it uses the hashcode to determine that. And if you want to use it as the key in a map, you want to make sure that when I update, the values of Kaushik's favorite things, and I use Kaushik Gopal as the key in that map, it's going to use the hash code to determine that it's updating the right objects.
Oh, okay. Yeah. Wow. There's like a lot of details that go into these things.
Yeah, absolutely.
Yeah, and if folks really want to dig into the equals and hash code a little bit deeper, that's in the Effective Java book by Joshua Block. We also did 2 episodes on that. Back in episode 31, we talk about overriding equals. And in episode 34, we talk about overriding hash code. So we have some content there if folks are interested. So this AutoValue stuff is super interesting. And I kind of want to go use it immediately. How do I use it? How do I install it?
Yeah.
Is it a jar or what does that look like? How do I get it? And then what? What does that look like?
Sure. So as I mentioned, AutoValue is a compile time annotation processor. So what that means is it's distributed as a jar, and you can use Gradle or Maven or whatever you use to add it. One of the important things to note, though, is that, especially for Android with Gradle, most of our dependencies we put in the compile configuration in our dependencies. So you'll say compile and then support library or whatever it is.
Right.
Okay.
With AutoValue, you don't want to do that. And the reason is that AutoValue is an annotation processor that runs at compile time. It's not actually adding its dependencies into your compiled APK, your running app.
Oh.
The reason that's important is if you go on something like methodscount.com and look at, how many methods are in there, because I don't want to go over the dex limit, it doesn't matter because AutoValue doesn't actually get included in your final app. So the way that you do that is in Gradle, you'll use the APT configuration, which is the annotation processing tool. And that makes sure that the tool is available at compile time for annotation processing, but not bundled into your final app. And so all of the, both AutoValue, which is on GitHub, that's a Google project, by the way, on GitHub. In the documentation there, and also the documentation for all of the extensions, they specifically point out, use the APT or provided scopes for this sort of thing. Once you've got it added as a dependency, then what you need to do is add the AutoValue annotation to an abstract class. And the way that AutoValue works is you write an abstract class that is your value object and uses abstract methods for the properties. And you simply add the AutoValue annotation, and the next time that you compile, AutoValue is going to generate an implementation of that abstract class for you.
Okay.
So the reason that it does this is that one of the ideals of AutoValue is that it should be a transparent API, meaning that your users, if you're writing a library or other developers on your team, should never need to know or care that you used AutoValue to make these value objects. When you create an abstract class, you're effectively writing the API for your value object, and that's what users are going to interact with, is your class. The fact that it's implemented by AutoValue is unimportant to users. One of the drawbacks of this is that you can't use constructors. Because this is an abstract class, we don't have constructors. So, but that's really a benefit, because that allows us to follow effective Java item 1, use static factory methods. And so with your AutoValue classes, your users will simply call a static factory method to provide whatever properties they want. And then the static factory method internally is going to construct the AutoValue generated object.
So this is a feature, not a bug.
Exactly.
Now, the question that I had is, so this gets built at compile time. Do I check these files into source code?
Not the generated files, no.
Okay. I guess those are put in the generated folder in the build output somewhere?
Exactly. Those are going to be inside your build folder. So just like you don't check in the compiled class files, you wouldn't check in these.
Okay. Excellent.
That makes sense. Quick question. You said, okay, I have to use abstract classes, which then means I can't use constructors, which means I would have to build my object, right? Do I have to use the builder methods in that case? And also, since we're like on a roll with reducing boilerplate with AutoValue, is there some alternative that I can use to doing that?
Yeah. So I had mentioned static factory methods, which is great if you have value objects that only have a few properties.
Right.
But as we all know, that never lasts very long. So AutoValue also has support for builders. And so basically what this ends up being is another abstract class that you annotate with an AutoValue builder annotation, and it will generate a builder class for you. And this builder, if you're unfamiliar with the pattern, basically allows you to set all of the properties via methods. And then once those are all set, actually build the final object. And what this does is it sort of, there are some other languages out there that use named parameters when you call a method. Java isn't like that, right? You don't say, create user, first name colon this, second name colon this. You just list them in order. And that gets really confusing when you have a whole bunch of strings that are required or something like that. So a builder lets you set those properties by name so that it's really fluent and easy to read. And AutoValue will generate that for you. And just like the AutoValue classes, the fact that you used AutoValue to generate the builder is unimportant to your users. So that's another abstract class that you simply write the API for, and AutoValue generates the code backing that.
Oh, so that's also a very interesting design goal that the library had. So technically speaking, I could, because it's an abstract class, I could come back tomorrow and say, actually, I don't want AutoValue. I'll just swap it out with something, and my API has not necessarily changed.
Exactly. That's one of the core tenets of AutoValue. And, one of the benefits for that, for one of my clients, I was writing an SDK. And so we had customers that were using this SDK. And so we used AutoValue to create these immutable value types. And our customers never knew or cared. And if at some point, We needed some functionality. We needed them to be mutable instead of immutable, and AutoValue no longer fits. They're abstract classes, so we can just create our own implementation and the customer will never know.
Ah, interesting. That's pretty slick. One last question I had about the implementation with AutoValue. Now, I haven't used AutoValue as much as I would like to, but I have noticed there's mention about this AutoValue prefix, right? So the generated classes have this AutoValue underscore prefix. What's the deal with the AutoValue prefix?
Yeah, so the AutoValue prefix is for the generated classes, the classes that AutoValue generates behind the scenes. But as we mentioned with this ideal of a transparent API, that's nothing that your users are ever going to use.
Gotcha.
Or you, when you use that class elsewhere, you don't use the AutoValue prefix. You use that internally in your static factory methods when you want to construct the actual implementation of your abstract class. You use the AutoValue underscore prefix. And the same thing for the builder. But outside of your implementation, outside of the AutoValue annotated abstract class, you wouldn't use that. And actually, you can't. The classes that AutoValue generates are package private. And this is part of their transparent API so that if you distribute a library that uses AutoValue to generate its immutable model value types, users are never even going to see the implementation because they're package private.
Gotcha.
So you talked about a couple of the benefits, mainly about the compile time only dependencies, that it has an invisible API, the users never know that you're using AutoValue, and so forth. What are some of the other benefits? Because I've been an IntelliJ user for a long time, and I wonder right away, it's like, well, why don't I just use something like the IntelliJ templates? What's difference there?
Oh yeah, good question.
Yeah, so IntelliJ does a really good job of creating templates and generating all of this for you. The challenge there is, so you've made this immutable value type. You used IntelliJ to generate getters and setters and equals and hashcode and toString and constructors, whatever. And then 6 months later, you need to add a property, right? So now what you have to do is you have to go, add that member variable into the class. And then you need to hopefully remember to delete the existing toString, hashcode, equals, and then recreate them. And so the challenge there is that it's really on the developer to remember that anytime they update anything in this class, they need to regenerate all of that stuff.
Oh, interesting. Okay.
Yeah, and so the AutoValue ideal is that's a waste of developer energy. We have a compiler that knows if we can generate all this stuff, we can just do it every time you compile. That way, it's always up to date. You never have to worry about forgetting to update the equals method.
Ah, yes. Oh, man. I can imagine how many times that would bite you.
Yeah, I didn't think about that, but you're totally right. If you change that object later on, oh man, it is going to be a pain.
Yeah.
Cool. So while we're on a roll with the benefits, what are some other benefits? I know we briefly touched on the thread safety thing. Are there any other points you want to add with respect to thread safety?
Well, I think, just to reiterate, now that multi-threading is so easy, thread safety is a big concern. And basically the concern around thread safety and value types is if you have a value type, say the credit card transaction, and some other thread, a service thread or something like that, changes properties on that instance, then you run into issues. You can never be certain that this value that I'm showing in the UI is current. And AutoValue, since it creates immutable value types, it gives you thread safety for free because you know that if you have an instance of an AutoValue type, it's always going to be valid. It's never going to be out of date.
That's true. The immutability, coming back to that.
Yep.
So now there's also something that you talked about in a blog post last year where you announced the AutoValue extensions.
Yeah.
What are the AutoValue extensions? How do I use them and why are they useful?
Yeah. So AutoValue by itself is super useful, and I've been using it for a long time. But it does one job, and it does it very well, to generate immutable value types. As an Android developer, that's difficult for me because a lot of my value types that I'm interested in particular, I want to be parcelable. And that was the big driver behind extensions. And we can get into some of the details of that a little bit more, but basically the idea is is I wanted more out of these implementations. I wanted to be able to customize it to fit my needs. And so probably about 2 years ago, maybe 2.5 years ago, I went to the AutoValue project, which, as I mentioned before, it's a Google project that's open source on GitHub. And I noticed that there were other people asking for extensions in that idea so that they could extend AutoValue and what it can do. And the alternatives at the time were forks of the project. So there were some other projects that sort of copied the implementation of AutoValue and extended them to specific needs. But the problem is that's not mix and match. If I want Json support and I want parcel support, I have to pick one or the other because these are forks. They don't work together.
It's like extending versus implementing, right?
Exactly. So what I ended up doing is one summer I ended up working on AutoValue and writing extension support into it. And so the idea here is there are other processors, other annotation processors that you can sort of add on to AutoValue. And AutoValue does a lot of stuff internally that's really, unimportant if you're a user, but it figures out, it doesn't matter what you name the methods, it figures out if there's a builder present, like all of that kind of stuff it does internally, and it does that really well. So it's very flexible. So what these extensions do is they're able to sort of hook into AutoValue after it's already figured out all of the details about your annotated class and provide added functionality. So a good example of this, and actually the first extension that was written was the AutoValue parcel extension. And what this did, like I said, was add parcelable support to AutoValue. And one of the things that I wanted to do with this was I wanted to make it super easy for developers, right? I didn't want, if you want parcelable and Json in addition to AutoValue, I didn't want you to have this 180 character long line of annotations that you're adding, right? So basically, since this ties directly into AutoValue, all you have to do to make an AutoValue class parcelable using the AutoValue parcel extension, once you have that as a dependency, all you have to do is add implements parcelable. And that's it. The extension is going to know when that is processed that it needs the parcelable bits generated for it too. And it's going to do that all for you behind the scene. And you've literally added 2 words to your class and you get it all for free.
That's it, huh?
That is pretty slick.
Yeah.
That's like magic.
Yeah, that's certainly the goal.
So I've used AutoValue parcel. So thank you for that. It works fantastic. I use
Excellent.
AutoValue already, so thank you again. What are some of the other extensions that are out there that are available?
Yeah. So when I wrote extension support, it was prompted by parcelable. But that's not the only thing it covers. It was meant to be flexible. And so one of the things I did off the bat, not only to make it useful for me, but also to demonstrate this flexibility, was add extensions for Json and Moshi. They're 2 JSON serializers, if you haven't used them. And if you work with any sort of web API, you likely work with JSON and probably even use one of these already. So what those extensions do is they generate type adapters so that you have a type safe way without reflection to serialize and deserialize your value types in Json or Moshi. So that's a really useful one. Another one is a Firebase data store extension, and that one I've been using on my latest Firebase projects, which is really useful, and it lets you easily get your value types from and put them in the Firebase data store.
Oh, that's fancy.
Yeah.
Yeah. If you don't use Firebase, if you use SQLite, as many of us do, then there's AutoValue Cursor. So if you use SQLite, it helps you read your value types out of cursors and write them to content values objects so you can write them into your database. Yeah. And lastly is an extension by Square called Redacted, AutoValue Redacted.
Right.
And basically, they work with finances, so they have a need to if they log or print objects using the toString, they want to exclude certain values, might be account numbers, something like that. So with Redacted, that adds another annotation, the redacted annotation that you can put on any property in your AutoValue class, And that property will not be included in the toString.
You know how many times I've written that myself? Oh my gosh.
So cool. So like passwords and maybe my music choices, all those we can add redacted to.
I've been using AutoValue for a while, but I recently ran into a couple of developers who are using a different library, and I'm probably going to butcher the name, so correct me if I'm wrong, but it's called Lombok. A couple of folks that I've met recently use Lombok, and it's, from what I can tell, it looks like an annotation processor that does similar things like reducing boilerplate. How is this different from AutoValue?
Yeah, so Project Lombok, it does very similar things to what AutoValue does in its goals. Its goal is to reduce boilerplate, and it actually does a lot more than just value types. It'll generate a lot of what your class needs. So constructors of different types, all sorts of stuff like that. It'll generate for you. What's interesting about Project Lombok is it sort of masquerades as an annotation processor, but it's not a true annotation processor in the sense that it doesn't actually comply with the annotation processing tool spec. So what it does differently is the documentation for Java and Java-C says that an annotation processor can generate new classes. That's all it can do. You can't modify existing sources. And so that's really sort of the underlying reason why AutoValue uses abstract classes and provides an implementation, as opposed to just letting you annotate any class and providing the implementation within that class. Because that's really forbidden by the spec. What Project Lombok does is they've sort of found this hack, and they use private APIs in Java-C and also ECJ, which is the compiler for Eclipse, to modify the AST, the abstract source tree. And so what that does is basically an annotation processor is provided an object-based representation of your source code. So things like a class object, which has method properties on it that represent all of the methods within your class. So an annotation processor is provided those so that it can learn things about your class, your source code, and then generate a new class, right? And that's exactly how AutoValue works. What Lombok does differently is it uses these private APIs to actually modify that AST. So with Lombok, you're not using abstract classes and then you get a different implementation. You annotate the class itself, and it modifies that in the compile phase so that by the time it's written to a class file, it actually has the implementation. Yeah, and that's actually one of the challenges, and one of the reasons that I don't use it is because there's some inherent risk there, right? It's using these private APIs and it's using the annotation processing tool in a way that is forbidden. So, if you want to use it, that's, a lot of people do, and that's perfectly fine. You don't really have to worry about your app breaking at runtime since this is a compile time thing, but you still risk having to re-implement everything.
Right. So you'll know beforehand if things go wrong, but like the thing is, if they do go wrong, it just involves potentially more work. And also, Project Lombok has been like around for some time. So like, it isn't like, oh my God, this thing is going to break like next version, right? Like, with the new release of Android Studio or something, things are not going to break here. But it is good to know.
Yeah. And it's a great project. I know a lot of people that have used it, and I've used it in the past, but that's a personal choice.
But you know what I think the true genius with Lombok is? It's the fact that they have project as a prefix. You create any library and call it Project X, that immediately adds so much legitimacy. Project Lombok versus just Lombok, I think has like some draw to it. So if you build something, Project AutoValue, I'll use Project AutoValue because it sounds pretty legitimate. And I just want to remind folks again that we've talked about AutoValue a lot, but the interesting thing is, like Ryan mentioned, Auto is like this suite of libraries that Google has created for basically just it's a collection of just like a whole bunch of like source code generating things, right? So there's like AutoValue, there's AutoFactory. Because I remember in a previous episode we touched this, and like Don mentioned there's like AutoFactory, AutoService, AutoValue, of course, and some other things. So this is like a whole suite that they brought in, out of which AutoValue is one that most of us Android developers have found tremendously useful, especially with some in conjunction with an extension like Ryan's for AutoValue Parcel.
Yeah, it's a great suite of tools, and we actually use some of the other tools. All of my extensions use auto service.
Oh, interesting.
Yeah.
Yeah, I've used that before too, and Auto Factory.
Very cool. Very cool. Ryan, wow, this is amazing. And I think we can keep going on and on. Like, I just have like so many interesting questions to ask. But I figure at some point you'll also have to get to work. So we don't want to keep you on. Thank you so much for coming on today's show and like helping us understand so much about AutoValue.
Yeah, thank you.
Yeah, thank you for having me. It's been great being here.
If our listeners want to reach out to you with more questions, or like if they want to ask for ideas and stuff, what's the best way they can do that?
Yeah, so the best way to reach me is on Twitter, and I'm R Harter on Twitter, RHARTER.
Perfect. And you also have a blog where you time and again write some amazing posts.
I do, yeah. It seems since I started doing Caster, I haven't been blogging as much. But
I wonder if there's someone we can talk to about that.
Right. So my blog is ryanharter.com, and in addition to Caster, there's also some really good information about AutoValue and lots of other Android coding topics at ryanharter.com.
And I hear if folks want to actually meet you in person, there's going to be an opportunity soon.
There is. So I do go to a fair number of conferences, and I have to travel so far to them that I thought it was about time that we had one here in Chicago. So I've been working with some other great developers and organizers, and this April 20th and 21st, we're going to be hosting Chicago Roboto, which is going to be the first Android developer conference in Chicago.
Wow!
Oh, interesting.
Yeah, so that should be a lot of fun. We've got great keynote speakers lined up in Jake Wharton and Jesse Wilson.
Who are those guys?
Yeah, you may have heard of them. But always a great time. And so 2-day developer conference in Chicago. You can go to chicagoroboto.com to order your tickets and submit a talk and find out more information.
Fantastic. Thank you so much again for coming on today's show.
Thank you for having me.
Alrighty, that's all for the show today, folks. We will catch you in the next episode. That's it for the show, folks. Fragmented is hosted by Don Felker and me, Kaushik Gopal. We edit all of the Fragmented episodes ourselves. The amazing Sarah from Spec helps us with production assistance and wraps our final mix. Our theme music and ad music is produced by the cool cat, Alan Taylor. You can find more episodes of the show on Pocket Casts, Google Play Music, or any of the other great podcast players in town. Our website is fragmentedpodcast.com, and you can find the links to all the stuff we say on our website. Thank you all for listening, and we will catch you in the next episode.